Okay, now we're going to take atoms and we're going to learn how to assign priority to the groups attached to them. We have learned that if the priority is clockwise, then we give an atom an R configuration. If the priority is counterclockwise, we give an atom S configuration. Now we're going to learn how do we give those priorities. These rules are called the Cahn, Ingold, Prelog rules, and basically what we're doing is it's as simple as just giving the highest mass atom the highest priority. So you look at the first atom attached to a chiral carbon or a chiral center, and you say which is the highest mass atom. The one that's highest mass we give number 1 priority to. The lowest mass one we give the 4 priority to. And it's that simple. But the thing is that sometimes the first atoms attached are the same. So what we have to do is find the first point of difference and then compare those 2 atoms that are different, and then we're able to assign priority that way. It's kind of like layers. The first atom attached, then the second atom's attached, then the third atom's attached. Anytime you find all the atoms being the same, you just go to the next level. Double bonds and triple bonds can be confusing because double bonds mean you have 2 of the atom attached, and triple bonds mean you have 3 of the atoms attached. But it's a little tiny bit more complicated. A carbon-oxygen double bond has 2 oxygens attached, but we also consider 1 oxygen to be bound back to the carbon. And if I have a triple bond, that we consider it to be 3 nitrogens attached, but 1 nitrogen is considered to have 2 carbons being bound back to it, or that it is binding back to 2 carbons. So we have to consider that when we do priorities. This can be kind of confusing. So what we're going to do is go through examples, and it's going through the examples that will help this make sense. We're going to look at this molecule first. It's a chiral carbon. You have 4 different groups attached. The lowest priority group is a hydrogen. And if I look at the remaining groups, I see 2 carbons and an oxygen in that layer. Oxygen is the highest priority group. Now I compare these 2. And I see to the 2 carbons, you have oxygens attached here and hydrogens attached here. So this one, oxygen has higher priority than hydrogen. So this is my number 2 priority group, and then 3. I'm going to turn this so that my lowest priority group is to the back. So now I look and I see highest priority, second highest, and then the lowest priority. If you look at how my marker is moving, you can see that we are going in a clockwise direction when I look at the priorities. That means that this is an R configuration. Let's now look at the enantiomer. The enantiomer is going to be a mirror image. So right now through here, you can see there is a mirror image so that it's reflected downward. It's the same molecule, just a mirror image. Because this is chiral, that's going to be its enantiomer. So we've got R here. This should be S because it's a mirror image. Let's look and see if this is how it turns out. I'm going to take my lowest priority group and put it back. I'm going to assign my priorities. The hydroxyl 1, the carboxyl group is 2, and then the methyl group is 3. What is the direction of rotation? It is counterclockwise, so this is S. Here is a chiral molecule. Go ahead and look at this and try to assign either R or S to it, and then we'll go through. Okay, if I look at this molecule, you will see that hydrogen is lowest priority, so I rotate that to the back. It's already back, but I will make it so that it looks a little bit easier. I assign priorities now. Bromine is the heaviest atom. And then if I compare these two carbons, this carbon has 3 hydrogens attached and this has 2 hydrogens and a carbon. This carbon outweighs a hydrogen, so it's higher priority up here. The rotation is counterclockwise, so it's an S. This is called bromobutane because you can see it's 4 carbons. So that's butane. On the number 2 carbon, we have a bromine. So it's 2-bromobutane. All of the halogens get an O ending on them. So fluorine is fluoro, chlorine is chloro, bromine is bromo, and iodine is iodo. This shows, if you didn't understand why methyl and ethyl are ordered like they are, this goes through it in greater detail. Here is a methyl and here is an ethyl. And I'm going to write them out so that you can see all the atoms attached. If I look at the priority, I see 2 carbons are the same, so 2 carbons are the same. Then I look at the next layer. The next layer is hydrogen, carbon, and hydrogen. I list them in order of priority. Carbon, hydrogen, hydrogen. These are all hydrogens. All hydrogens. Now you can see the carbon is higher priority than the hydrogen, so this group, which is this group, gets a higher priority. Always, well, it says draw out attachments. I don't think you really need to draw out attachments. What works for me much better is to draw out the layers like this. And if I go out and I look at this, I can see these 2 groups being compared. Carbon, carbon, the same. What's attached to this carbon? Carbon, oxygen, oxygen. So I list them in priority. Oxygen, oxygen, carbon. What's attached here? Oxygen, hydrogen, hydrogen. Oxygen, hydrogen, hydrogen. So if I compare these atoms to these atoms, I see the oxygen outweighs the hydrogen. So this, which is this, which is this, has a higher priority. What is the order of priority for these? You go ahead and try to assign the order of priority for each of these groups. Okay, if I look at this, all the carbons are the same, so I have to go to the next layer. Chlorine, hydrogen, hydrogen, oxygen, oxygen, hydrogen, carbon, 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 and nitrogen, hydrogen, hydrogen. This group up here has a chlorine, so that outweighs everything else. The next group that has priority is oxygen because it outweighs carbon and nitrogen. Then I compare the carbon to the nitrogen. Nitrogen is heavier than carbon, and then carbon is the last. So these are the order. So let's go through some more examples here. If I look, this right here is an aldehyde group, and over here we have a hydroxymethyl group. The carbons are the same. The next layer out is oxygen, oxygen, hydrogen. The next layer out here is oxygen, hydrogen, hydrogen. Because oxygen, oxygen, hydrogen gives a higher mass than oxygen, hydrogen, hydrogen. The oxygen weighs more than this hydrogen. We give it higher priority. Even if I add another oxygen on the outside, it doesn't change the priority because it's not in the first layer, it's in the second layer. This is still oxygen, hydrogen, hydrogen, and this is oxygen, hydrogen, hydrogen. This second layer doesn't matter. It's still 2 oxygens outweigh 1 oxygen. If I look at this vinyl group compared to this ethyl propyl group, 1 ethyl propyl group, you will find that the vinyl group is lower. Why? The first layer is carbon, carbon. Then we have, in the second layer, carbon, carbon, hydrogen. Here we have, again, carbon, carbon, hydrogen. Then I go out 1 more. I have carbon this carbon here is bound to 2 hydrogens and backbound to a carbon. So for this, what's attached to this carbon, you have carbon, hydrogen, hydrogen. And here, if I look, the next one out is carbon. No. There is carbon. Yeah, the next one out is carbon, hydrogen, hydrogen. It's the same as this one. So we have to go even further. And what do you find is on the last carbon, you have hydrogen, 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 and you don't have anything out here. So this is lower priority than this group. Here are some more examples. I'm going ahead and highlighting these so you can see it even better. Carbon and carbon are the same. Then the layer that we consider next is carbon, carbon, hydrogen. What do we consider here? Carbon, carbon, carbon. So that's higher priority. If I look at this one, we have in the second layer out carbon, carbon, hydrogen. What do I have in the second layer out? Carbon, hydrogen, hydrogen. That's higher priority. If I look at this, carbon, carbon, hydrogen, and then here, carbon, hydrogen, hydrogen, higher priority. Okay, so here's some problems to go ahead and try and do these, assign, starting with this compound, assign priorities, and then assign R and S, and we'll go through it step by step. So do this one and then pause the lecture and do this one and then restart it. Okay, if I look at this, I'm going to show you that the lowest priority group is a hydrogen. And so then we have bromine, then ethyl, and then methyl. You can make a model and take the hydrogen and put it to the back, or you can grab the carbon-hydrogen bond like a stick in your head and turn the molecule around and look at it. Or I'm going to show you a trick that works. It's really simple and works well for most people. The hydrogen is coming out here, and it's supposed to be going to the back. So what we're going to do is we're going to say the hydrogen's coming out, and it's supposed to be going to the back. So if I assign priorities to the remaining group and look at the rotation, I actually have to flip the configuration to get the right one, because I would have to flip the hydrogen back to get the opposite configuration. So if I look at this, I'm going to assign 1 to bromine, 2 to the ethyl, and 3 to the methyl. That is counterclockwise rotation. So the hydrogen's coming out, and it should be to the back. So I just say then, well, it's not S for counterclockwise, but the opposite, R. If I rotate it in my head and put the carbon-hydrogen back, you would find the bromine is here, ethyl is here, and the methyl down here. And again, you can see that's clockwise rotation, so it is R. Go ahead and pause the lecture and do this molecule, and then I'll go through it with you. Okay, the priorities of the group are 1, 2, 3. The hydrogen is out. That's clockwise rotation, so this is S. If you drew the molecule and with you putting the hydrogen back behind, you can go through it and see it drawn like this. 1, 2, 3. You can see that's counterclockwise and S. If I look at this molecule, you can try it and then restart the lecture. Okay, if I look at this carbon right here, this is the chiral carbon. The hydrogen is back, so I don't have to worry about redrawing it or turning it around in my head. The highest priority group will be all this over here. The next highest priority group will be this chain, then the methyl. So if I look at the priority, it goes 1, 2, 3, which is clockwise. It is an R configuration. Here we have 2 chiral carbons. Go ahead and assign chirality to these and then restart the lecture. Let's start with this one up here. You can see the hydrogens coming out, so I know whatever rotation I get will be opposite to assign the right configuration. The highest priority group, this one's a little bit hard to figure out. If I really, there's one carbon here, one carbon here. Here there's one carbon attached to two carbons. Here there's one carbon attached to two carbons. So I actually have to compare these two groups to see which is the highest priority. If I look at this carbon, it has carbon, carbon, and a hydrogen attached up here that is not written. If I look at this, carbon, carbon, and a hydrogen that's going back behind. So I've got to go to the next layer. This carbon here is bound backward to one carbon and then to two hydrogens. This carbon here is bound to one carbon and two hydrogens. Okay, so they're the same still. Let's go one more out. There's no more out for this. There's one more out for this. So I have carbon, hydrogen, hydrogen. This is the higher priority group. So highest priority, second, third, hydrogen coming out, counterclockwise, flip to R. Okay, this one is showing you the information right now. The highest priority group is right here. Second highest priority group is down here. Third, right there. That is counterclockwise rotation. The hydrogen's back so we don't flip it. It is configurations. And restart the lecture. Start here, go here, then here, then here, and here. Actually, I think it's 1, 2, 3, 4. We'll go through it. Assign them all, and then restart the lecture. Okay, if I look at this, there's 4 different groups. Very easy. The hydrogen's already back. Bromine, then, iodine, then bromine, then fluorine. So that is counterclockwise rotation, so it is S. If I go to the next one, 2 groups are the same, so it is achiral. If I go to the next one, what do we see? We've got a bromine is highest, then chlorine, then methyl. The hydrogen is up. If I turn it so the hydrogen goes back, the methyl goes up here. So it goes bromine, chlorine, methyl. That's clockwise, so it is R. If I turn this one, the hydrogen's here going out this way. I can actually see the rotation. Highest priority, second highest priority, third. That's clockwise, so it's R. Here the hydrogen is coming out, so I'm going to have to flip my rotation. So what's highest priority group? All have carbons attached. Then this is carbon. This carbon has oxygen, oxygen, oxygen attached. This is oxygen, hydrogen, hydrogen, and this is carbon, carbon, carbon. So this group is number 1, this group is number 2, and this group is number 3. If I look at the rotation, it goes clockwise. Sorry, my pointer's not moving. It goes clockwise, so the rotation has to be flipped. So it is counterclockwise and S.